those are the only ones that are able to crack a tribulus seed because they can get their beak in between the spikes, and then they're strong enough to be able to crack the coat. So it's like the last pistachio nuts. As the drought is going on, everybody else has cracked all the easy seeds on the island. The last pistachio nuts, the one you need the nutcracker for at the bottom of the bowl, only those fortunate few with the right beak at the right time were able to get a meal by the end of that year. And that's why they were the ones that survived. Only 15 in 100. Well, among Geospiza fortis, as among many animal species, the males tend to be bigger than the females. That's a phenomenon called sexual dimorphism, and evolutionary biologists study that, the reasons for it, why might it have evolved. It's a general rule among fortis. So the result is that at the end of the drought, there are many more males that have survived than females. In fact, 6 times more females have survived than males. That means that when the rains finally came at the end of that drought year, and the island suddenly turned green again, and the birds began to sing on the cactus trees, the males sing to attract the females, and then the females fly around and check them out, listen to the song, check out the height of the perch on the cactus tree, and apparently check out the beaks of the male birds too. They had their pick. The females had their pick of the males because there were six times as many males as there were females. So that was an episode, of what Darwin called sexual selection. And sexual selection operated, again, with uncanny intensity at that moment among Darwin's finches. So you have birds that are remarkably variable, that have gone through a remarkably intense selection event, very, very tough drought, and are now the largest, with just those beaks, being selected with remarkable intensity by sexual selection and natural selection. They breed, they pass on their genes. The next generation is strikingly larger and has a striking number of these excellent tribulus cracking beaks all over Daphne major. It's such a striking change that you can see it with the naked eye on Daphne major from one year to the next, although, of course, the grants and their grad students and their students have collected all these numbers and crunched them in computers. They have supercomputers that can crunch the toughest. I'm sorry, I'm making a little pun here, but I'm not going to pursue it. But they found that, in fact, they had seen evolution in action. And that is the theme of Chapter 4 of The Origin, natural selection or the survival of the fittest. The birds had undergone natural selection, survival of the fittest, then this bout of sexual selection. The variations had been inherited, and you had a striking evolutionary change. I'm happy to say that a few years later in 1983, and it was a Nino year, El Nino made the island incredibly wet, and suddenly, within a week, it was covered with grass. It rained so much that the birds bred and bred generation after generation. There were many generations within that one wet year, and the pressure is now reversed. And can anybody guess why they might have reversed during that wet year? They could eat other seeds. Good, that's right. And grass seeds, which had covered the lava, hid the tribulus seeds. So if you were a big-bodied bird with a big nutcracker beak, this is relatively speaking compared to all your neighbors and cousins, you couldn't get those tribulus seeds. And a big-bodied bird needs a lot more seeds to sustain it. The little guys who had the equipment to crack those little grass seeds were the ones who ate and ate and ate. And the big guys were at a disadvantage. And I, as not representing one of the big guys of my species, I'm always happy to say that the pendulum swung the other way. And now it was the little guys with those grass seed beaks that were favored by natural and sexual selection. And this little two-step that the birds had taken in one direction, they now reversed and danced in the other direction within a matter of a couple of years. So that's only one of hundreds, literally hundreds of episodes of evolution in action that the Grants and their students and now many other biologists are documenting in the islands. And they have demonstrated with fantastic precision that variation can be a matter of life and death, that the smallest grain in the balance really can determine who shall live and who shall die, and that it can produce evolutionary change. And if climate changed in a way that didn't swing back pendulum-like from one state to another, from wet to dry, if, for instance, one imagines these birds arriving in the Galapagos for the first time some millions of years ago, blown off course, perhaps in a Nino year from South America, blown way out to sea, landing in those islands, they arrived in a situation very different from the one in which their ancestors had lived and flourished. They were under selection pressure at least as great as those Fortis are on Daphne Major today in the swings of climate, only the climate didn't swing the way it's doing now. For them, conditions remained extremely, severely different from the rainforest of Ecuador, what is now Ecuador, from South America, where their ancestors lived. I hope I'm remembering this right, in a matter of 20 successive steps as large as that one that I just described in the drought of 77, you would have built a bird as different, one from the next, as the median beak ground finch to the large beak ground finch on Daphne Major. You would have gone from one species to another. Or if the pressures were all the other way, you would have gone to the small beak ground finch. There are now, from that ancestral colony, which consisted maybe of just one pregnant finch, we don't know, that would have done it. From that ancestral colony, there are a baker's dozen of species of Darwin's finches in the islands. So I'm trying to decide how much time we have and whether I can tell you a little more about the beauty of this variation. You can now go down to the level of the DNA with Darwin's finches, which you couldn't do when I was writing about Peter and Rosemary, to my sorrow. I hoped that I would be able to back in the early 90s, and the tools weren't really there yet. But a few years ago, Peter and Rosemary began collaborating with a group of molecular biologists at Harvard, led by Cliff Tabin. And they did the study that I dreamed that the Grants would do while I was writing about them. They looked at the level of the genes to trace the variation to the level of the genes and see what is being selected for at that ultimate level of variation. And they found a signaling molecule called bone morphogenetic protein 4.
Is that going to be on the test?
Yes, it is. BMP4, write it down.